2016 Physics 1 again, so no calculus here, but I pulled this question because it is a design your own experiment question, so I wanted to talk through it. A new kind of toy ball is advertised to bounce perfectly elastically off hard surfaces. As the students suspect no collision can be perfectly elastic, the student hypothesized that the collision is close to for low speed, but they deviate more and more for perfectly elastic at high speed. Okay, great. Design an experiment to test the student's hypothesis about collisions of the ball with a hard surface. The student has equipment that would usually be found in a physics lab. What quantities of measures, what equipment? Okay, great. Okay, so here's the thing. What we're going to do is we're going to drop the ball from low heights, so it's going pretty slow when it gets to the ground, and drop fast heights. Okay, so what we're going to do here is we're going to drop the ball from low heights and see how high it bounces. Okay, we're gonna drop the ball, and so this tests low speed collisions. Drop the ball from high heights, right? We'll say, like, I don't know what low and high is. Let's say low heights, so less than 1 meter, and we'll say from 3 meters, because it's not really reasonable to say a physics classroom is going to be much taller than that. Drop the ball from high heights and see how high it bounces. Okay, so this tests high speed collisions. And so what quantities are measured? All we're going to measure are heights. So we're going to measure heights. And then we're going to have a meter stick is what we need, taped to a wall, okay, and a camera, a phone camera, to film the ball to precisely see how high it rises. Okay, cool. Describe the procedure, okay, to test the student's hypothesis. Give enough. Okay, so drop the ball from low heights, right? So I think we've got that. So if we were going to be procedure, tape, so obnoxious, takes so long. Tape meter sticks. We need meter sticks, plural, to wall, to drop ball from 1 meter. Actually, let's do it 0.5 meters, right? So that we can really get a difference. With bottom of ball at 0.5 meters. Film the drop to see on playback where bottom of ball is on rebound. So obnoxious. Great. Repeat to, let's say, 4 more times for 0.5 meters. 5. Repeat 5 times for 3 meter drop. Okay, cool. Describe next, that's our procedure. B, describe how you would represent the data in a graph or a table. Okay. Explain how the representation will be used to determine whether the data is consistent with the student's hypothesis. So I would have something like on a table. Actually, if we wanted to see if there's a trend on this, repeat 3 times for a 3 minute. Actually, let's do 5. Repeat for 1 meter, 1.5 meter, 2 meter, 2.5 meter, 3 meter. Okay, great. And so then B, what we're going to do is graph bounce height versus initial height. Okay. So H bounce versus H original. So if linear hypothesis is false because H bounce equals H origin, original, right? If the graph has a negative concavity, therefore the higher the original, the more change in height, right? So that would mean the student's hypothesis is true because as you go up, there's more of a shift from that linear relationship that you're expecting, all right? A student carries out, so that's my B. A student carries out the experiment and analysis described in A and B. The student is immediately concludes that something went wrong with the experiment. There's a graph or table shows behavior that is elastic for low, but appears to violate a basic principle at high-speed collisions. Oh, so in other words, if we end up with more energy, so this is CI. Give an example of what it would look like, okay? Right, so that would actually be a positive concavity because it would say more energy in the system post collision. So that would be dramatically wrong, yeah. Okay, oh, yeah, so more, so this violates law of this is my II, conservation of mechanical energy, okay? Briefly explain why the axis of the graph, yeah, that's all done. Great, so there you go.